the stream is up because, yeah, we're late.
Amazing.
We're 15 minutes late.
Whatever.
We get it. Wow.
Soon we'll be on at 3. No?
No, soon we're going to be on at night.
Well.
Soon. When? When? Wait, I didn't hear you say soon. Talk again.
Soon.
Oh, you got to speak up. Yeah, your microphone does not pick up your first soon, sir.
Oh, it's fine. Talking quieter.
Well, you better talk louder.
Nope.
We need to hear from you.
Nope.
We're ready to believe you. Yes, we have great music by Harris Heller, so we can sing over it.
Harris.
Yeah, you got to move your mic closer, because guess what? That's the second time I've not picked you.
You'll deal with it.
You know, we could just kick you off the show.
Okay.
It'd be pretty boring.
Alrighty.
It would just be me. I wouldn't do that to Corey, but if we couldn't hear you, what would be the point of having you?
Roscoe be here.
Although he doesn't stick around when I do the show by myself, except for one. This week. But the other week. Good song by Harris Heller. Yeah, hey everybody, welcome. Don't all crowd the door on the way in. We know you're excited.
Tesla.
All right, I'm going to call 10 seconds.
Batteries.
10 seconds, you ready? Darn it. I'm going to call 20 seconds.
What's wrong with you? What? This part of your stream. Get a little bit. Nope.
5 seconds.
5,
3, 2. Hey. I got my beverage. Hey, everybody. Welcome. Not Your Average Show. Mike and Corey. What is going on?
What is up? It's a Wednesday.
September 22nd, Wednesday, 2021.
September.
We're in a mood.
Middle of the week.
We are there, ready to give you guys the best episode we can possibly today.
On Wednesday afternoon.
On a Wednesday afternoon. How are you, Corey?
Well, I am doing well. I'm doing worse now.
I never did that in the episode. Anyhow, yeah, it's a
We
Wednesday.
are in the same room, as you can tell.
As you can tell, because my hand can teleport through walls and go right over to Corey's location. Yeah.
Awkward.
So you're doing well? Everything's good?
Yes.
Cool.
No, nothing to talk about.
What's that?
Nothing. Yeah, I'm good.
All right. Well, cool. Hey, we got a lot for you in today's episode. We're going to be talking about Redwood, a battery developer with the co-founder of Tesla, making an impact in doing its own battery development. So that's going to be, I think, from Redwood Materials. Also, we'll be looking at Paragon Aerospace VTOL, or their Soar aircraft, and they made an agreement with the township of Brownsville, Texas. So that's kind of interesting. And then finally, to wrap up today, Corey and I both have a lot of flight experience. And with that, we know we've said often that there's going to be a different rider experience for people that are going to be the back end of urban air mobility VTOL aircraft, or eVTOL aircraft, or whatever you want to call it. But whatever these Archer, Jobbies, and all these other new things that are coming out, they're in for a little bit of a surprise when you realize what it's like to be in a light aircraft below 15,000 feet and what it's actually like to go through that experience. So we're going to talk about that from our own personal videos and explain to you why there's challenges that people aren't really quite telling you about the UAS market and how it's going to work out. Correct?
Yeah. The actual user end experience. Now, what we'll elaborate a bit later on that. Of course, we can't comment on, the check-in process, or what's going to happen to the bags, all that. But we're literally kind of just talking about the experience when you're on board the aircraft, of a light aircraft.
Yeah.
We can show you some clips, which we'll do in a bit.
We can do that. Okay, so with that, it is time for Corey to take the stage to tell us about this one that he pulled up, which is the something about the Tesla co-founder making his own gigafactory kind of deal.
Well, yeah.
Something, right? There you go. And it's all yours, sir.
Cool. All right. So this one is just a quick thing about Redwood Materials. And the article here is from carbuzz.com, and it basically talks about Tesla co-founder has another $1 billion idea. And in this article, it talks about Redwood Materials, the company, and the gentleman in talking about is J.B. Straubel, which, if you guys know anything about Tesla's kind of history, you'll recognize the name. But this gentleman was at Tesla as the co-founder and the CTO, where he basically built really good engineering things for early days of Tesla. But this we're talking about is he's now over at Redwood Materials, and just reading from their own page, they talk about what they are looking to do is help make EV batteries really accessible for the EV market. And what we're talking about on the show is because this is going to happen in America somewhere.
Hmm.
They are planning on talking about this. Well, we're getting more information about the location in spring 2022, so not that far away. And they're looking to supply some of the materials for the lithium ion process. And specifically, they're looking at, let me pull it up here. They're looking to the anode and cathode materials, which we primarily use for lithium ion batteries, or we source them a lot of times from Asia in this case. They're going to be making those for manufacturers, but making it in America. We don't know where the location of this plant is going to go. That should be announced early 2022, which we've about. But the idea is that pulled up down here some actual things. So by 2025, Redwood aims to be able to produce 100 gigawatt hours of the cathode active materials for the anode foil for about 1 million electric vehicles per year, and then they're looking to ramp that up by 2030. They're looking for making about 500 gigawatt hours, which should be, depending on capacity of the vehicles they're going to go into, roughly about 5 million electric capacity for that. So that in of itself should help the demand. I know we talked about on the show too, with sourcing supply for electric vehicles as they are supposed to be prevalent. Not just people wanting to buy them more, but being sold more. And with things happening, there are some more interest in electric vehicles. I don't know why or not, but I mean, just recently we saw the new Cadillac Lyric sold out their pre-reservations in like 12 minutes or something crazy.
Yeah, but they said
I mean,
that
there
it
wasn't
might
a
not have
whole lot of
those.
them. I know there wasn't a whole lot of them.
There
I
wasn't
get
a
that
whole
too, but anyway, there's still some interest in that, of course. So this should be pretty interesting.
Yeah.
I mean, we know at least the person at the head of it has some past chops, knowing how to get something off the ground that's going against the grain of the automotive industry. If you follow me there, as far as getting Tesla off the ground, and now he's over here trying to work with batteries. So, I think, man.
I think that these guys, I mean, strategically, what it looks like, and I'm just going to flash this one up here because this is also something that's in the news, that they formed a strategic relationship with Ford as well.
That's just today.
That's just today.
That's straight. That press release is from today.
Yeah, that's straight up from today. So I guess part of it is that yes, these are a foundling company that is looking to do the recycling battery thing, as well as how they attack in their own words, the periodic table of elements. Okay, and how they're going to go about providing us with these new materials that are going to be definitely prevalent in making sure that we have enough battery technology along the way to supply our EV future. That's a massive thing, right? Especially the fact that, again, you said that he has the gentleman that's in this process, which is, again, I had his name up here.
If you go to the
leadership,
go down, yeah, JB Straubel. Yeah, right.
Oh, say so JB Straubel. Obviously, he's a prior to founding it, so he spent. He found the company. He was a co-founder and the CTO of Tesla. So obviously, this is almost like, hey, I did it for these guys. And there's obviously a different way of going about the business where everyone else is going to want to have access to the same, I guess, structure that Tesla has on their closed market for their battery, development of their gigafactories.
Right.
They're probably just bringing the same process out to the open public so that they could basically sell Tesla style batteries to all, maybe.
Well, I think that's the one thing I wanted to point out when I was talking there. I didn't specifically mention that Redwood Materials is going to be building battery components for not one particular manufacturer. They're going to be making, it appears, different manufacturers. As
right.
Seen. Ford is particularly in the one press release just from today. So that's exactly as you mentioned. They're going to be doing it for different companies.
Right.
Kind of just to help with the supply chain itself. Have it be local America.
I wonder if Elon has a stake in it. Number one, I wonder how much of him, how much blessing he said, look, I'm not going to hoard all the technology that we're going to develop for Tesla for ourselves because, there's definitely room for outsourcers in this production line. So I'm wondering how much he has knowledge of this, and I guess, for the most part, maybe he's given it his blessing. I don't know. I
I don't
wonder.
know the answer to that. We do know that, and you guys would see too, that if you do Google search for any kind of for Tesla recycling its own batteries, they're also well on the way to recycling a whole bunch of the materials of their own batteries.
Hmm.
And so they'll be doing that too to try to help keep reclaim what they can reclaim out of the old packs and them into some products or random, products that are reclaimed. But yeah, I mean, more supply is always good, as we know. There, supply chain problems. Look at any supply chain problems right now. Knock-on effects after the pandemic and whatnot. I mean,
Yeah.
in a way, it stifles some, not so much, I wouldn't say innovation, but stifles the ability to get things to market. Obviously, stretch there.
There's
I
lots
mean,
of
obviously
companies
that's the whole
having that
thing.
problem.
Can't get material to market. So,
Sure.
and that, as we know, sometimes business runs a timeline. And have maybe you wouldn't take too far to envision really good companies that have really good ideas, and for various reasons they either don't get funding or don't get supplies, and then that company just doesn't make it. So, um, having more
Interesting.
materials is and you would hope having a surplus of X would mean the price would go down as well,
Not
and
in
you
this
would
market.
then you would also hope that that would get passed on to the but I don't but
We don't know
we'll
that.
see.
Yeah, I guess my thing is right now with the chip shortages and everyone else going through hemorrhaging and trying to make up the difference between what's available in the marketplace and what's not. The average cost of materials has risen. Inflation is on the rise. So this is a good jump in the right direction to try to get the prices down by using these recycled elements to basically make up for what we don't have out there right now for public consumption, right? So hey, it's something to watch. It's something to keep an eye on, and especially as this EV market grows. Looks like Redwood Materials has got the pedigree, and let's see if they've got the legs to go to the distance.
Yeah, I'd be also interested to see if when we move on, as we covered on this channel too, that the battery technology is kind of changing. The battery chemistry is a bit changing,
Right.
and I would be interested to do a little more research on this company to see if they are situated to be able to provide whatever new materials go into the next version of the batteries. Versatile enough to, I
Hmm.
mean, yeah.
There you go. Hey, folks. So we're going to be following this one again with more battery technologies. It's one of the places that we like to hit on as part of the investment strategies that you might find for materials in the EV future, which everyone is predicting is going to be huge. With all that money out there, just remember this is just one of those ones that came up as a spotlight that has some probably good legs to stand on and might be worthy of another look. Even though they're not publicly traded at this time, there might be other associated materials or some future, I guess, moment when they're going to go public or would like to go public. So, something to keep an eye on. All right.
Yeah, certainly.
All
Yep.
right, let's move on. So, like, subscribe, follow. Let us know what you guys think in the comments below, and we'll be happy to follow up on this one and give you more information. Okay, so leading into the next discussion, which is going to bring up the last discussion of the day, something popped up today on one of the sites that we go to, which is SUSS News. Uh, which I don't know. To me, it was just kind of interesting because it says Paragon VTOL, Aerospace announces a partnership making Brownsville a leader in vertical launch technology. Something that caught my eye. It said Paragon VTOL Aerospace, a lead innovator in vertical takeoff and landing technology. VTOL, obviously, released a press statement basically saying that, hey, here we go. We're going to go ahead and develop a partnership with Rolls Royce, SNC Electric, ARUP, and Texas Southernmost College, the City of Brownsville, and Greater Brownsville Incentives Corporation. And looks like these guys are getting ready to go ahead and commit towards starting a partnership there to, I guess, lay ground for their new facilities. So it was just one of those things where I kind of said, well, all right, that's interesting enough. Let's take a look a little bit more at maybe what Paragon offers by the numbers. And if you go to their website, we hadn't seen anything from this company before, so it was just interesting to take a look.
Yep.
This is their entry, which is basically being called the Paragon Soar.
Yep.
Oddly enough, it looks like a cross between multiple designs that we've seen here on the show before. It looks like it's going with a hybrid blade structure, which is basically some sort of large blade structure and then a Lilium-esque smaller almost nested baby motor structure to offset some of their thrust. And they're talking about different levels of propulsion, meaning that there's some sort of 70 decibel engine on board. So it's quite a unique perspective and a different take on the urban eVTOL market, and even more so, their Paragon Soar, which we just looked at some video for. The thing is, I'm kind of questioning where they get this idea that they are a leader currently in this space, because ironically enough, they say that their estimated delivery is 2024, contingent upon FAA, EASA, and CAA approval, and that a full scale validation testing will start in 2022. They're saying it has proprietary carbon fiber construction, a frost resistant airframe, hybrid electric propulsion, again, the 70 decibel engine, 500 horsepower electric motor per ducted unit,
Yep.
and a 5 passenger plus pilot. Yeah, interesting. And micro propellers for reduced noise during takeoff and landing, 500-mile range. And then it says the photo is a rendering of an actual VTOL under development. Final version will be based on the FAA approval airframe, which may alter the commercial ready vessel. So VTOL. So, hey, it's kind of an interesting concept. They do have another one on here, which is called the Paragon Soar Ambulance, which obviously is going to be their entrance into the EMS world, which is someplace right now where helicopters enjoy pretty much dominance in that industry for servicing the air ambulance sector. But it is a place that we anticipate that, VTOLs will go eventually in the future. It just makes natural sense. So with that, Corey, what's your feelings on this one?
It's always interesting to find new companies doing different things. As Mike said, we hadn't not heard about, or I had not heard Paragon Aerospace, so we stumbled across talking about this article for today's show, and it's I don't mean to sound like the same thing I always say, but I like to know more.
I'd like to know more.
It says a hybrid electric propulsion system. It mentions a 70 decibel engine. I don't so I guess that's their well, I guess it's the power plant for, I mean, it mentions hybrid electric, so it's not fully electric. Obviously, it says hybrid electric. So does that mean we're looking at something that would run the main engine? Is it maybe a small turbine or something, an APU
Possibly, yeah.
for takeoff? High. Well, I mean, it would make more noise then. Would you think if it was
A little bit.
I don't know. Maybe they use the electric part to take off and land, and then use the quote more noisy engine at altitude. I don't really know. I'd like to know more. Speeds and endurance, as we always talk about airplanes, aerial vehicles. What's the endurance? It does, of course, mention estimated delivery 2024. Obviously, contingent on some certification procedures. They do mention FAA. They do mention EASA. They do FAA. So they're looking to go international, right? So this is while they say going into Brownsville. For this main article, there's 50 aircraft of theirs going into Brownsville. They are looking to go international. I don't know. I mean,
so this design,
for me, I feel like this is a lot of rotating components.
Yeah, so that's what I'm trying to figure out here, because here
my guess would be that, because remember, anything that spins faster has a higher tip speed will make more noise.
Yep.
So maybe they're planning on using these 8. Are those larger? Are those larger? There's like one on top, one on bottom. Are they doubles? Double stacked?
Really,
can you tell?
Honestly, I really can't. They're double stacked. They might be double
because
stacked.
of the double stacked, you might
like
be able
it,
to get
maybe.
away with spinning them a bit slower. And since there's 8, which is significant, maybe you can reduce noise.
They might be double stacked. Could be double stacked.
I don't know. Obviously, just speculation here.
So here's my thing, right? So they're going after, obviously, the clean design of just big bladed system, and then they're going out with these other ones that are over the wings. So I guess in forward flight, these wings will produce additional lift, but the difference is they've got these embedded micros, which they're quite an interesting design.
Banks of 7
or so. But my first question is, how are you going to get in and out of the thing? That's going to be real interesting, because you're either going to have to walk over the wings, or you're only going to be able to ingress or egress from the front of the aircraft with some sort of door opening.
I hadn't thought of that.
That's going to be pretty difficult for, number one, how are you going to get it out? Number two, the last thing that I'll say, which is going to kick off into our direct next conversation, is I don't know how that's really going to respond to air mass, because that tail, the way that sits in forward flight, will be stability, but a lot of that other surface area is going to be very reactive towards clouds and lifting air masses, and that's a lot of stuff to be pushed up and down again. So I'm not sure how smooth their ride is going to be.
I don't know.
Saying.
Yeah, I don't know. I mean,
Could be interesting.
It says it's a 6-passenger size, so it wingspan wise, it looks fairly large,
right?
You know, and I know we keep comparing stuff to like Jet Aptera, but Jet Aptera at least looks like a small footprint.
Sure.
Although you could imagine, again, this is a UAM, you know, urban air mobility application, right? Still probably looking to go in existing heliports and other places like that. So it probably would still fit on existing pads, but anything of a significant size, again, I don't know. You know, we're always again, I talk about endurance, we talk about weight, I talk about kind of batteries got on board. But yeah, I am just a bit, I just like to.
Yeah, it's something to take a look at, because again, when these companies announce big S packs where there's going to be big money involved, again, we know that this market is looking, basically it's the flying car market, and we know that people are hot to get in on it. But the question is there any real money in this particular venture? Because with all the other designs out there, this marketplace is getting crowded. Okay, getting real crowded. So it's worth noting. So like, subscribe, follow. Let us know what you think, and we're going to get more information on them if we can. But this leads us to the final part of the discussion today, which is going to be a little bit longer and a little bit more in-depth as to what we see as some of the challenges right now that are facing the urban eVTOL market. And that is what the ridership experience is actually going to be like when people finally, by all means, get on board one of these aircraft, and what their expectations are going to be, and how their actual experience will go.
I mean,
right?
Me, as we kind of segue into this part, anybody watching this clip later, have you been on a small aircraft? And I mean, like, small single engine Cessna, something of that size. Small, well, any kind of helicopter. Have you been on a helicopter? And where did you go? How long was your flight? How was the ride?
Mm-hmm.
And we'd like to hear that stuff in the comments below. So just put some stories down there, and we'll. Yeah. Station goes.
Okay, so the difference between what general people know, most people's experience in flight, is sitting in the back of a major air carrier, usually in an aircraft with a length of over 100 feet long and a wingspan somewhere in, usually 60 feet or greater. And the difference being is that those ride at different levels in the atmosphere, different speeds. And obviously, you've known, if you've ever been in the back of one, anything from an Embraer 145 or a baby Learjet, or even up to, say, an Airbus, or larger A320, all the way up to 747s, they do eventually hit turbulence, and they do eventually shake. And the reason for this is because the Earth's surface heats unequally in different segments, because a grass surface will absorb solar radiation at a different rate than a mossy surface, which is dark, and a watery surface or some other feature will heat at a different rate if it's covered with trees. And then finally, the terrain might actually have wind passing over it, which will actually launch air currents, especially coming up and down mountains, so high up into the atmosphere that it creates turbulence along your route. Okay? And this is pretty fairly common. And if you're in a small aircraft, it's generally, and I do say generally, expected that your ride will be a little bumpy.
Yeah.
Depending on what you're flying over. So the first
time of day. Yeah.
Yeah.
Yes, exactly.
Right. So actually, that's another thing. Corey, you just brought it up. If it's daytime and the sun's out, ride's going to be generally bumpy. Nighttime, temperatures cool off. It's going to be a lot less bumpy. So you're probably going to see a lot less surface heating. And when we talk about convective currents, that's a rising column of air. Okay, hotter air. And when we see convection, that's usually going to lead to some sort of thunderstorm or cloud activity, which means the ride will get bumpy. So the first example that we have for you here is, and just so everybody knows, every one of these videos that we're about to show, the time that these videos were taken, because I know personally when they were taken, no one that was in command of the aircraft was not abiding by their duties, number one. Number two, no passengers were being transported for compensation or for hire, including in the jet ones. We were actually ferrying the aircraft, so there was no actual passengers on board. And lastly, everything was done that there was a pilot monitoring everything else going on inside the aircraft at the time. So if anybody has any questions about that, you can write into the show all you want, but that's the only time the camera comes out.
We know we might get a few comments. What are you guys doing? Taking video when you're flying?
Right. Okay.
Was the way it is. Commercial optics.
There you go. So for the first one, we're going to cut over to basically this is a Bell 407. This is approximately 600 feet. We're operating under a cloud layer, and this one's going to be over land. And you're going to see that this camera is going to shake a bit. I'm going to go ahead and give you the audio. Stand by.
Still playing. It's a bit strange.
That's weird. Hold on. That whole
Whoops.
thing just crashed. What do you know?
Technical difficulties
On the
on a live
first
show?
video.
That's so crazy.
Really? Well, let's try this again, shall we? Wow, that thing just totally locked up.
Totally just went bye-bye.
Yep, went hasta la bye-bye. All right, let's try this again.
Excellent.
Yeah, I always love when
These
that
things
happens. By the way, we tested this all before the show
Oh
launched.
yeah.
And everything played fine. And now all of a sudden we
That's how
tried
it
it
goes.
and, it crashes first time out. So we'll edit that part out. So here we go. Try this again. This first video shows you guys basically what it's like to be in a Bell 407 about 600 feet flying on a day with partly cloudy skies, average temperatures around 80 degrees and roughly about, again, 600 feet. And you can see that the camera's going to shake quite a bit. And this is the type of ride that one person could expect at this particular moment in an aircraft like this. And as you can see, this is a backseat ride, and the cabin is actually pitching on its axis, and you can see that the ride is fairly bumpy. Now, in comparison to that, this one is going to be a slightly different video. It's going to be the same aircraft, same day, different location. This time, this is going to be out over the Gulf of Mexico, roughly 1,000 feet, cloudless skies, same air temperature, same conditions. And this one, you're going to notice that the aircraft is actually way more stable. And Corey is going to speak to you a little bit about why that is.
Yeah, so again, this one's offshore. You can see quite a nice day. But one thing we also mentioned, that air's a bit more stable. There's not as much varying differences in where the air is trying to move. So when air is not at the same temperature in one place, the air wants to move around and get to a bit of equilibrium or rise as hot air does, right? And you get some air movements. So, but offshore, it's all water, it's all ocean.
Mm-hmm.
Ocean basically heats up at the same rate, and so everything's pretty stable.
Right. Okay. So, and what you may or may not know is what we know in the business is something as winds flow from high to low, right? So if there's a high pressure air mass, right, and it's sitting in an area, what's going to happen is that high air pressure air mass is going to try to fill in the location of a low pressure air mass, right? And what we generally know as a guide is when we're looking at the surface, low air pressure usually means that it's hot and less dense and likely to rise. And what forms this other column of air underneath it is actually the high pressure air rushing in to squeeze or the pressure differential around it. So now we're going to go into a different aircraft. This one is in a Cessna. This one we're operating, I think, about 1,000 feet. It's a partly cloudy day. It's more humid, generally more overcast, just in a mid-level layer of air. And this is probably going to be one of the areas that these aircraft that people are looking for urban air mobility might be operating on a regular basis, because you're only going to do short hops of under 50 miles. To go to 10,000 feet or higher is nearly a waste of time and energy. So here we go. Without further ado, this one is just a basic Cessna, about 20 seconds of a clip. And you can see once again the stability. The camera's shaking a little bit. It's a fairly smooth but a little bumpy ride, as we're kind of in between two layers at a basic altitude on your everyday standard flight. Okay, not to be outdone though, this very same flight, just moments later on final approach, actually yielded totally different results. This one is coming in on final, and we're a little lower in the altitude. No, excuse me, this one's just below the clouds. We're not on final yet. This is just below the clouds, precip on final. Yeah, this is the one. So take a look at this one. A little different, and now you're going to see the camera bounce around quite a bit more inside of this precip, these moving air masses. And you can see the camera stability is a little different. So that's part of the dynamic here. So let's talk about that one a little bit more. This is on average weather that you might encompass just about anywhere in the country, any given day between, say, spring to fall.
Yep.
So the ride can be fairly bumpy.
And I mean, I think one thing we'll point out is probably everybody out there has driven in a car, but then encounters a rainstorm on a road that's really heavy rain and maybe gets a bit uncomfortable with how heavy it is. Whether that's the road surface is a bit wetter, more wet than you like, or visibility is just really low and you're kind of uncomfortable with that. One thing to always keep in mind about maybe the comparison there is, in a car, you're still on Earth, like touching the ground,
Mm-hmm.
and the car can obviously move in some directions, but it doesn't have that next dimension that you do in the air.
Right.
Obviously, everybody, when we're talking about training people to fly, you could always pull a car over. You can always pull over if you need to. That stuff doesn't happen in the air. And these are things that obviously, as you're listening to us talk, of course, right, Corey, Mike, of course that's the case.
Sure.
But if you're in an air taxi or an urban air mobility vehicle, it's just something to keep in mind that if you have people that maybe haven't really been on a boat, haven't really been airsick before, that's just not something they're used to, and then they get on something that's relatively light comparing to like a bigger jet, these lighter vehicles.
Right.
The same weather that would not affect a larger aircraft as much will affect these because they're lighter. What speed? Some of these are going to go fairly quick, but a lot of them are going to be a bit slower.
Mhm.
That's why we're showing you these videos to compare the altitude and airspeed that is somewhat comparable in weight of aircraft to what you would envision we'll be getting it in air taxis. We know some air taxis are planning to go a bit slower. We know some planning to go a bit faster. There's different ones. We get
Which
that.
makes a
Which
difference.
we've covered a whole bunch of those.
Right.
We understand that. This is kind of just to give you an idea, and maybe have you think about things you thought about if you yourself have not really spent much time in or any time in a light aircraft at relatively low level.
And,
Is
and
the
here's the
whole
big
idea.
thing. Speed makes a difference. At 140 knots, and a lighter aircraft is going to react differently than an aircraft that's going at about 250 knots because that sweet speed is about 200 knots. 200 knots gets you to go fast enough where you can ride through these currents fairly quickly and not have it impact the ride as severely, okay? So this one we're going to go to, this is your average day of flying. This is mid-level, roughly about 8,000 feet. You're just above a small layer of clouds. Otherwise, what would be considered a perfect day of flying, and you're going to see that this is going to be a fairly smooth ride.
Looks great.
Looks great.
Yep.
Camera's barely bouncing.
Nice VFR weather.
Yeah.
All right, that's something else we haven't talked about, particularly IFR versus VFR.
Oh, we'll go into that.
But we'll probably get there in a moment.
Yeah. Okay, so now the one that I played in Era before was, now we're going to go back and just take a look. I played this one while Corey was speaking because this is actually what it's like to be on a final approach in this level of clouds. Now we're below clouds, 600 feet, final approach, a little bit of light precipitation. This is not extreme weather because you can actually see through it. You'll actually see on the actual approach that we are on here, you can see half the airfield is covered in sun. The other half is covered in shade from the clouds. And we're going to roll this clip and you're going to see how absolutely bumpy this can get. Okay, so the difference there is that, look, everybody could turn around and say, oh, you're just not stabilizing the camera. No, 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 no. When you're an occupant inside the aircraft, the aircraft is doing what it's wanting. You're trying to hold the camera. And this is basically why you get the type of shake that you see in the camera. So nothing there has been different. Now, this next one is a little different because we showed this one. I'm going to show you this one. This one's a little bit longer. Okay, now I believe this one is the cloud entry. And what we're going to basically be listening to is when we actually enter a cloud with this particular type of aircraft, well, you're going to see that the engine pitch is going to change and the airspeed may fluctuate. And that's because there is rising columns of air. So let's just give a listen to this one. I'm going to turn the volume up. We'll be a little quieter so maybe you guys can get a better listen on this one. And we'll let this one play out. Here we go. Okay, so it didn't seem very extreme, but you could hear that the engine pitch was changing because the aircraft was struggling as it went through this rising column of air. And let me tell you something, that ride gets pretty bumpy. I don't think people are ready for that experience that are going to think that they're going to get on this this aircraft, and they're going to feel like, oh, this is great. And guess what? The ride's going to be a little bit more bumpy than they think. So the next one, do you have anything to add on that one?
No, I mean,
Okay. This next one is what we're going to take a look at in this particular aircraft video is going to be a little different. I want you guys to bring your attention down below. You might hear a little bit of engine pitch change. You might hear something different, but if you look just below, you're going to see that one of the primary flight displays actually indicates the airspeed and the altitude, roughly 6,000 feet, going through clouds again. And this time you could watch the actual airspeed fluctuate. And on top of that, you're going to hear the engine pitch change again as this aircraft does penetrate another cloud. And here we go with that. All right. So that one again, you can hear roughly the same experience as the aircraft starts to pitch up a little bit there. And look, this is just average everyday flying when you're in a small aircraft. It's not uncommon to be sitting there and occasionally get a little bit of light on your seat feeling where your butt literally rides out of the aircraft seat for a second there because of these rising columns of air. Okay, so now we're going to go on to what we're going to call another average day video. This time we're going to be surrounded by clouds that are trying to make their way into the cumulonimbus stage. They're trying to climb, seeing a little bit of pillowiness, but they're just about the time where they're just too early to become vertical, real turbulent. But you're just trying to just get through these clouds at a clip, and we're going to see how the aircraft really gets affected here as well. See this little bit of bounce.
it probably would be worthwhile just to mention that these these images where we are, if anybody out there is informed, IFR versus VFR, IFR certified, VFR certified, the aircraft and the pilot were current and rated properly to do all the operations you see in the videos. Again, I'm just saying that because you never know who's going to see the video.
There you go. All right, this last one. Okay, this was during a ferry flight, and there was no passengers on board, just to go ahead and say that. This was just pilot monitoring, decided to break out a camera and see what it was like to be at the tops of the cloud layers as basically, this is the average experience for everybody else. You're sitting in back, but this one's a little different, as we're going to see that it's a fairly smooth flight, roughly about 14,000 feet, 250 knots of airspeed. And as you're just above this layer, most of the rising columns of air and everything else that we see is fairly neutral. The ride is fairly comfortable. Until just a little cloud like that, you can turn around, you can see that the aircraft started to move a little bit more. And there was a little bit of reaction there. And then finally, this is the last one of a full penetration into a cloud layer. And speed makes a huge difference in the experience for the passengers and for those in back, because the speed, like I said earlier, of which you transition through this type of flight, it kind of smooths out the bumps because you kind of skip through it like water, like a boat on water. The faster the ride, sure, the jolt is a little bit of a different frequency, but it's not unsettling. And I think people have to be aware of, as we move closer into this, urban air mobility market, that you're going to get a different feel. So depending on the structure of these aircraft that people are going to use between Lilium, Archer, and so on and so forth, they're all going to have different lifting components. And each of those lifting components is going to have a different feel on the aircraft when dealing with things like turbulence.
Yeah. I mean, since they're not all the same, like, basic design as airplanes, like, these are small airplanes, these are larger jets, comparing kind of basic airplane design to basic airplane design. We have different propulsion systems, different size of propellers, different wings, or sometimes no wings, or sometimes lifting bodies, but they're not really, they don't look like wings typically, cookie cutter wings. So I guess what we're trying to just emphasize is in addition to all the other hurdles that we talk about as far as battery capacity, certification, obviously where they're going to land, noise, all the things we already talked about in terms of urban air mobility becoming a thing, is just to be sure that when people get on, they're going to have a positive experience to the point they're going to want to get on again, right? Because
Right.
that's still a business model. They want people to repeat customers. That's still obviously a thing. So I guess it might just be something to control expectations.
Yes.
Like you would do with any kind of business, you want to be sure the customer knows what to expect before they get there, so that they're not surprised and they may not have a negative experience. And thus, because have a negative experience, you're going to be much more likely to remember the negative experience than how great every other flight was really nice and smooth, but that one, oh man, that one flight was really bad.
Right.
Stuff like that. So I guess that's kind of what we wanted to bring this up for. Have a thought and have a bit of a conversation with you guys in chat as well. From our experience, of course, we've shown you a little bit of the clips, but have you been on a bad flight for weather-wise or turbulence? And why was that? And how big was the plane? And where were you going? And we're curious to know those kind of things, and to see if anybody else has thought about that for these kind of coming up.
Sure. And part of the thing is, look, helicopters always fly a little bit nicer than airplanes and their counterparts because, believe it or not, there's a certain amount of flex that's built into the rotor head, the design of the actual blades to flap and absorb some of that rising column and settling columns of air, which a rigid wing aircraft usually does ride a little bit harder than that. And because of these aircraft being slightly hybrid, meaning like the Volocopter, which does have a disc that is made up of much smaller rotors, right? It's going to be interesting to see how how they actually handle this because we've seen the video that they had from the fly-in, and it seemed like it still got moved around quite a bit.
Yeah.
Not a lot, but it could be smoother. But if you look at, say, a Lilium, I expect a Lilium style aircraft to probably fly a little bit more like a traditional Cessna, and where I would anticipate, say, an Archer, that type of design, which has a hybrid design, once again, a propulsion made up of lift that's coming from both rotating devices and not, and even the Delta variant that's out there, right? Not COVID, but I think it's the Delta, the Delta Aerospace entry, I think is what they call it, right? That one's gonna fly a little differently, and then we come to have a different advantage because speed and their design of their wing and the way that they're making their propulsion may actually have a way to smooth out the ride. So it's just something to be thought of and think about for the future as these markets still emerge and as we're looking at all different types of designs and which one's going to be more successful. Hey, they're all going to have to share the same space, the same air, the same clouds, the same weather, same conditions. They're all going to have to deal with it. And there's really no way of getting around the fact that for all the convenience that people want and something that's going to be like the flying car, be prepared because air has turbulence, which is just as good as any pothole. And the only other thing is you can't usually see it coming.
I
You
mean,
kind of just have to deal.
depends, but yeah, exactly. You can expect it if you know what to look for, but again, pilots, we go through a lot of weather, so that there's some of that there. But sometimes, yeah, sometimes it's clear air or whatever, and boom, you get some bumps, and it can happen. So
There you go.
yeah, but yeah, it's just something to talk to you guys about and see what people are thinking.
Yep.
This is something anybody else is, and I don't mean the engineers, of course, I thought of, but I'm talking about like you, the customer, that's open to ride one of these one day from your local town to somewhere close by.
Yeah. So there's that. Hey, folks, let us know what you guys think in the comments below. And we'd love to hear from other experienced pilots to comment on what their experiences have been in smaller aircraft and getting jostled around. It's happened before. And let us know what you think about the emerging marketplace and how you feel this is going to impact attracting customers towards these short hop urban air mobility aircraft in conditions that might be less than ideal.
Yeah.
It's going to happen.
Yeah, and I mean that was another conversation we've touched on a few times, was the VFR versus IFR operations, not certification of the aircraft or even the
Mhm.
pilots themselves, but really like at what line do you draw where people, passengers, paying customers would have possibly such a poor experience on the flight with weather related issues that you
Mhm.
would choose to not take that operation
Yeah.
for that particular sortie, right? That time frame, lot to Tampa or a particular one, because if you do that, the aircraft's gonna get there, not worried about that, but they're not gonna have a great time. They're not gonna want to
No.
do it again, and so is that something that's also being worked into business models? And we would like to hear about those kind of things.
Yeah.
So if anybody else says that too, operator wise, weather limitations, we know actual limitations for the regs and stuff. What is there going to be another like soft line for like op specs, let's call them, for these kind of air carriers, depending on distance and speed and altitude, where they say, okay, passengers aren't going to like it past X, whatever, we're not doing it.
There you go.
Yeah.
All right, folks, let us know in the comments below. Thanks for tuning in today. We appreciate your time and your energy. And once again, thanks for your subscriptions, because the subscriptions have been really good.
Thank
and
you.
We couldn't be any more pleased. And we'll be back at you with another show tomorrow.
Yes, excellent.
There you go.
Cool.
Thanks for tuning in. We'll catch you guys real soon. Have a great day.
Take it easy. Roscoe says bye. I don't know if
Bye.
you can see him in camera, but he's here.
He's here. We know he's here. He's
Roscoe.
always here. He's like our mask. Well, he is.
Yeah, man.
Oh, yeah. They've been fun.
It's been like clear flights. That's
Oh.
another thing too. Just because you're just listening, wrapping up the show. Even clear flights, we had some students on board that got sick. Never got car sick.
It'll happen.
Something to see what happens with.
There you go. Thanks, everybody, for tuning in. We'll catch you real soon. Have a great afternoon.
Take it easy.
Bye-bye.
Bye-bye.